Dear students, in the previous lecture, we have understood about indefinite integrals. Today, we are going to discuss about the definite integrals. In definite integrals, we have limits a and b over the integral. This is called definite integral. It means that there is some function f of x bounded by the curve x equal to a and the line x equal to b. So, the area under this graph, under this function f of x, bounded by the lines x equal to a, x equal to b and x-axis is called the definite integral from a to b. Dear students, there are two fundamental theorems for integral calculus. First fundamental theorem of integral calculus states that let f be a continuous function on the closed interval a to b and let a of x be the area function. Then derivative of a of x, that is a dash x, is equal to f of x for all x belongs to a to b. Dear students, let us discuss the second fundamental theorem of integral calculus. This is also called as a backbone of definite integrals. Let f be a continuous function defined on closed interval a to b and capital F be an antiderivative of small f, then f of x integral from a to b is equal to f of x from a to b is equal to f of b minus f of a. Dear students, now let us solve some problems based on the fundamental theorems of integral calculus. We have integral of x square dx. Let us take the limits from 1 to 2. We can see that the function x square is continuous in the interval 1 to 2. Then we can apply the fundamental theorem that the antiderivative of x square is x cube by 3. We will not write c here. We will put the limits 1 and 2 because this is a function f of x. We will put f of 2 minus f of 1 here. So, the answer would be 2 cube minus 3. We have put the value of x equal to 2 here and will subtract the value 1 cube by 3 from 2 cube by 3. That is our final answer. That means 8 by 3 minus 1 by 3, which is equal to 7 by 3. Now, in this problem we can see we have an integral of x plus 1 from the limits minus 1 to 1. First of all, we will find the antiderivative, that will be x square by 2 plus x. Now, we will directly put the limits x equal to 1 and x equal to minus 1 in this antiderivative and we will subtract those. Now, we get 1 square by 2 plus 1 minus of minus 1 by 2 square minus of 1. That means we get 1 by 2 and 1 by 2 got cancelled and 1 and minus of minus 1 will be 2. This is our answer. In this problem, we have 1 by x dx from the limits 1 to 2. First of all, we will find the antiderivative of 1 by x, that is equal to log of mod x. Now, if this is f of x, we will apply the second fundamental theorem of definite integrals, that is this will be equal to f of 2 minus f of 1. That means log of mod 2 minus log of mod 1. Now, we all know that log of 1 is 0. That means the answer will be log of 2. This is our answer. Now, in this question, we have the integral of sine 2x dx from 0 to pi by 4. So, first of all, we will find the antiderivative of sine of 2x, that will be minus cos 2x by 2, which is equal to f of x. Now, we will find f of pi by 4 minus f of 0 using second fundamental theorem of definite integration. Now, we will see the value of f of pi by 4 is minus cos twice of pi by 4 by 2 minus of minus, that will plus cos twice of 0 will be 0 by 2. Now we know that the value of cos pi by 2 is 1 and cos 0 is we know that the value of cos pi by 2 is 0 and the value of cos 0 is 1. So we'll apply these values here. So we get 0 plus 1 by 2. That is our final answer. Now in this question we can apply the standard integral of the function 1 by under root 1 minus x square dx, that will be equal to sine inverse x. So that is our function f of x, that is the antiderivative of the given function. Now we have to find the definite integral of this function, which will be equal to f of 1 minus f of 0 using second fundamental theorem of definite integrals. The answer would be sine inverse 1 minus sine inverse 0. Now we know that sine inverse 1 is equal to pi by 2 and sine inverse 0 is 0. So our final answer would be pi by 2. Dear students, now we'll try to find some integrals by the method of substitution. Now we can see that the question is 5x raised to the power 4 under root x raised to the power 5 plus 1 dx, then the limits are from minus 1 to 1. Now we'll substitute x raised to the power 5 plus 1 as t, and we can see that the derivative of this on the left hand side is 5x raised to the power 4 dx equals to dt. We will substitute all here, but we have to change the limits also. Now we can see that if x is equal to minus 1 here, if we put x is equal to minus 1, we get t is equal to x raised to the power 5 plus 1, which is equal to minus 1 raised to the power 5 plus 1, which is equal to 0. And when we put x is equal to 1, that is our upper limit, this is the lower limit, and this is our upper limit. Now when x is equal to 1, then t would be equal to 1 plus 1, that is equal to 2. So we'll change the whole question and the limits would be from 0 to 2 and the function would be changed to root t dt, right? So now we can apply the antiderivative to root t, that will be t raised to the power 3 by 2 upon 3 by 2, and we'll apply the fundamental theorem of integrals. We'll put the value 2 here, that would be 2 raised to the power 3 by 2 upon 3 by 2 will be equal to 2 by 3 minus 0 raised to the power 3 by 2 upon 3 by 2, that would be 0. Now the final answer would be we have 2 cube and the root 2 is there, so we'll have 2 by 3, 2 cube is 8 and root of 8. This will be equal to, we'll take 2 common from here out of the root, that will be 2 into 2, that is 4 root 2 by 3. That is our final answer. In this problem, we have tan inverse x upon 1 plus x square and the limits are 0 to 1, that is the lower limit is 0 and upper limit is 1. We will substitute tan inverse x is equal to t and the derivative of tan inverse x is 1 upon 1 plus x square dx will be equal to dt. Now the limits will also change. We have the lower limit as 0, then t will be, for x is equal to 0, when x is 0, t will be tan inverse 0, that is also 0, and when x is equal to 1, we have t equal to tan inverse 1, that will be equal to pi by 4. So we'll change the question here to the new variable, that will be, the limits will be from 0 to pi by 4, and tan inverse x is equal to t, and 1 upon 1 plus x square dx, this whole part will be dt. So now it will be very simple to solve. So we'll apply antiderivative here, that will be t square by 2, and apply the limits. So we'll get pi by 4 whole square upon 2 minus 0 whole square by 2, which is equal to pi square by 4 16 and 16 into 2, 32 minus 0. That is our final answer is pi square by 32. Dear student, let us solve some more problems. We have integral x upon x square plus 1 and the limits are from 0 to 1. Now we'll substitute x square plus 1 as t. So the derivative is 2x dx is equal to dt. That means x dx is equal to half dt. Now we have to change the limits also. We have x is equal to 0, then the t would be equal to 1. So the limits would change to 1, 2, and when x is equal to 1, we'll get t is equal to 2. Now we have x square plus 1 as t. So we have 1 by t, and x dx as 1 by 2 dt. We'll put 1 by 2 in front of the integral, and we have 1 by 2 integral 1 to 2 1 by t dt. Now we'll apply the simple integral formulas. So 1 by t integral is equal to log of mod t, and the limits are from 1 to 2. By applying the fundamental theorem of definite integrals, we get the final answer as half log 2 minus log 1, that is equal to half log 2, because log 1 is 0. Dear students, now we are going to do the next most important part of the definite integrals, that is how to find the integrals using the properties. Now we'll study some properties. We have zero property, that is integral of f of x from a to b, that is the limits are from a to b, and the function f of x dx, we have to find the integral of that. Now if the variable x is changed from x to t, that is the function is changed from f of x to f of t, even then the integral will remain same, because finally after finding the antiderivative of f of x or f of t, we get the function where we have to put the upper limit and lower limit and subtract that. So no matter if it is in the function of x or a function of t, the answer would be same. Now if we have the second property here, that is called P1 property. In this, the integral from a to b f of x dx is there, and if we reverse the limits, that is from b to a, there is a minus sign which is introduced in the front of the integral. Now in the third property, that is P2 property, we have integral a to b f of x dx. We can split this in the form a to c f of x dx plus c to b f of x dx. That means, let me explain through some graphical calculation. We have this function f of x, and we want to find its integral from a to b. That means this area, this is our shaded area. Now if there is some point c inside a and b, we can split in the form that the area, we can calculate the area first from a to c and then from c to b. We'll get the same area which was calculated on the left hand side. Now the next property is P3 property. In this we have integral from a to b f of x dx. The value of the integral will remain same if we apply the theorem, that is the integral from a to b f of a plus b minus x dx. If we replace x by a plus x minus x, even then the integral will remain same. We will apply this in number of problems. So the next property is P4 property. This is a particular case of P3 property, that is the integral from 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That is, we have replaced x by a minus x because the limits here are 0 to a. So the next property P5 is 0 to 2a f of x dx will be split in two parts, that is 0 to a f of x dx plus 0 to a f of 2a minus x dx. In the next property, we have the integral f of x from 0 to 2a is equal to twice 0 to a f of x dx if f of 2a minus x is equal to f of x, and this value will be equal to 0 if f of 2a minus x is equal to minus f of x. Now the P7 property is split in two parts, that is the first part is the integral f of x from minus a to a is equal to twice 0 to a f of x dx if f is an even function, that is f of minus x is equal to f of x, and this value will be equal to 0 if f is an odd function, that means f of minus x is equal to minus f of x. Dear students, now let us solve some problems based on properties of integrals. We have integral from 2 to 8 mod of x minus 5. We know that x minus 5 is a function which is greater than or equal to 0 for x belongs to 5 to infinity, whereas x minus 5 is less than 0 for x belonging to minus infinity to 5. Now we can see that we have the function from 2 to 8. So what we want is we have to split this function in two parts, that is from 2 to 5 f of x dx, that will be mod of x minus 5 dx plus 5 to 8 mod of x minus 5 dx. Now we can see that we have applied property P2 here. In the function in the limits 2 to 5, mod of x minus 5 is less than 0. That means if x minus 5 is less than 0, the mod of x minus 5 will be minus of x minus 5 from limits will be from 2 to 5. Now the value of x minus 5 mod will be greater than 0 if the values of x lies from 5 to 8. So this will be x minus 5 integral. Now we have two parts here, that is integral 1 and integral 2. We can separately solve them. We have the value of I of 1 is from 2 to 5 x minus 5 dx with the negative sign, which is equal to minus of x square by 2 minus 5x, which is equal to minus of 5 square by 2 minus 5 into 5 and minus of 2 square by 2 minus 5 into 2, that will be equal to minus of 25 by 2 minus of 25 minus of 4 by 2, that is 2, and minus of 10. Now we'll find the integral I2 in the similar manner, and I2 will be equal to x square by 2 minus 5x, and the limits will be from 5 to 8. If we calculate these values, I2 will be equal to 8 square by 2 minus 5 into 8 and minus of 5 square by 2 minus 5 into 5. So if we calculate I1 plus I2, it will be equal to 9. So now let us do a problem, that is under root of sin x by under root of sin x plus under root of cos x, and the limits are from 0 to pi by 2. We will apply the theorem, that is the property f of x dx from 0 to a is equal to 0 to a f of a minus x dx. This property we'll use here. Let this integral be equal to I. Now, I will be equal to 0 to a. We'll also give this I as equation number 1. Now, we'll find 0 to pi by 2 root of, we'll replace x by pi by 2 minus x because here a is equal to pi by 2. By comparing, we'll get sine of pi by 2 minus x root by root of sine of pi by 2 minus x plus root of cos of pi by 2 minus x dx. Now, we know that sine of pi by 2 minus x is cos x and cos of pi by 2 minus x is sine x. So, we get 0 to pi by 2 root cos x upon root cos x plus sine x. Root cos x plus root sine x can be written as root sine x plus root cos x using using commutative property. Now, let us give this equation number 2. Now, when we add 1 and equation number 2, what we will get? I plus I on the left side, that is equal to 2I, and on the right side we get the two integrals with the same limit. So, we can add these two from 0 to pi by 2 root of sine x by root sine x plus root cos x dx plus 0 to pi by 2 root of cos x upon root sine x plus root cos x dx. So, we get 2I equal to 0 to pi by 2. We take LCM here, root sine x plus root cos x, and the numerator will also be same. It is root sine x plus root cos x dx. So, we got the answer as 0 to pi by 2 1 dx. So, we know the answer that integral of 1 is x and the limits are from 0 to pi by 2, which is equal to pi by 2 minus 0 is equal to pi by 2. Now, we have 2I equal to pi by 2, then I will be equal to pi by 4. This is our final answer. Dear students, let us solve a very interesting problem. We have integral sine raised to the power 7x and the limits are from minus pi by 2 to pi by 2. We know that when the limits are from minus a to a, what we have to check whether the function is odd or even function. For that, we have to find whether f of minus x is equal to f of x or f of minus f of x. So, first of all, we will find f of minus x. We have f of x equal to sine x raised to the power 7. Now, f of minus x is sine of minus x raised to the power 7, which is equal to minus of sine raised to the power 7x, which is equal to minus f of x. So, we can easily see that the given function is an odd function. So, the integral can be directly written as 0 because we know that the integral from minus a to a f of x dx is equal to 0 if f of minus x is equal to minus f of x, that is f of x is an odd function. Dear students, we have done definite and indefinite integrals in details. We have also done various methods to solve indefinite and definite integrals. We have also done properties of integrals. I hope you have understood the lecture thoroughly. Thank you.